Ladies and gentlemen, please take your seats.
Να το ανοίξω, να...
Μπορείς να το βάλεις έτοιμο.
Κάπου που να... εγώ, δαμέ.
Ladies and gentlemen, good morning. Please take your seats. We will commence in 1 minute. Thank you.
The problems are really accumulating. People start becoming aware of climate change and they see in their daily life that it has an impact. And this is going to continue and it will actually accelerate. You see in many countries that heat records are being broken every year. This is something that is continuing, so it can lead to security problems, it will lead to problems in agriculture and water availability. These heat extremes in particular are going to affect the Middle East and North Africa very strongly. We think that the heat extremes also and the drought has contributed to the civil unrest in Syria, so we really need to address these problems to make sure that in future we prevent these very negative outcomes of climate change.
Climate change is going very fast in the region, faster than almost everywhere in the world. And also air pollution is extremely bad. This is due to growing population, as well as the vicinity of the two largest deserts in the world, the Saharan Desert and the Arabian Desert, that will generate a lot of dust in the air. Climate change will get worse and worse. This will create huge issues related, for instance, to migration, and this is currently a big issue in Europe. So we have to adapt and mitigate climate change already today to prevent such issue that would happen in the future.
Cyprus is a member of the EU, but it is also in the Middle East. This region is an environmental hotspot of change. We see here influences from West Asia, from Europe and from North Africa, and we can see the combined signal, this combined effect of the influences in Cyprus.
It's a big threat for the Cypriot population, but it's a great opportunity for our center to investigate long-range pollution from these different continents.
EMME-CARE project stands for Eastern Mediterranean Middle East Climate and Atmosphere Research Center. It is a project funded by the European Union through the European Commission's framework program called Horizon 2020. The Cyprus Institute is coordinating this effort, and we have advanced partners such as the Max Planck Institute for Chemistry from Germany, the University of Helsinki from Finland, and the Commission for Atomic Energy and Alternative Energies from France. We are already running through the first phase of the EMME-CARE project, and we have a second phase to submit a proposal for it, and we are going to aim to establish a center of excellence which is going to run for at least 15 years on the funds.
This Center of Excellence is not just pursuing excellence in science, but also innovation with new products, new services that are currently missing in the Middle East. We have organized very recently an international conference on air pollution and climate change with the objective to bring together science and policy. And this was a big success because it has attracted a lot of attention to all over the region and has created a new dynamic that is currently supported by the government of Cyprus to establish the island as a regional node for climate change.
Έχουμε αναπτύξει μια συνεργασία με το Ινστιτούτο Κύπρου. Η συνεργασία έχει υποστηρίξει την προσπάθεια της Κυπριακής Δημοκρατίας για να μπορέσει να αναπτύξει τη στρατηγική προσαρμογής, τα μέτρα και τις πολιτικές αντιμετώπισης των θεμάτων της κλιματικής αλλαγής. Υπάρχει μεγάλο πεδίο εξειδίκευσης και γι' αυτό πιστεύουμε ότι μέσα από την περαιτέρω ενδυνάμωση των σχέσεων και των δράσεων μεταξύ της κυβέρνησης και του Κύπρου μπορεί να έχουμε ωφέλιμα και ουσιαστικά αποτελέσματα τόσο για την Κύπρο αλλά και ευρύτερα για την περιοχή της Ανατολικής Μεσογείου.
The Center of Excellence will do something for the region and for Cyprus. It will provide information on how to best cope with climate change. And we are not going to be able to prevent it. We can hopefully prevent the worst, but it will happen and one needs to be prepared.
Kalimera, good morning. Honorable Minister for Agriculture, Rural Development and Environment, Dr. Kostas Kadis, Head of European Commission Representation in Cyprus, Mr. Yerothros Papadopoulos, Your Excellencies, ambassadors and heads of diplomatic representations from European member states, countries of the region and the world, Finland, France, Italy, the Netherlands, Cuba, Egypt, Israel, Jordan, Lebanon, Qatar, Australia, representative of the Cyprus Greens Party, former Minister of Foreign Affairs of Cyprus, Mrs. Eratoko Zakou Markouli, former European Commissioner, Mrs. Androula Vassiliou, Environment Commissioner of the Republic of Cyprus, Ms. Ioanna Panayotou, National Chief Scientist for Research and Innovation of the Republic of Cyprus, Mr. Kyriakos Kokinos, European Commission representatives, Ms. Carla Rocha Gomez and Mrs. Federica Roffi, directors and department heads of ministries and organizations of the Republic of Cyprus, Ministry of Foreign Affairs, Ministry of Defense, Ministry of Agriculture, Rural Development and Environment, Department of Environment, Department of Forests, Department of Meteorology, Department of Labor Inspection, Cyprus Fire Service, Cyprus Civil Defense, Agricultural Research Institute, Directorate General for European Programs Coordination and Development, Research and Innovation Foundation, professors and scientists from the universities in Cyprus, the University of Cyprus, the Cyprus University of Technology, the European University Cyprus, and Frederick University, members of the Board of Trustees and friends of the Cyprus Institute, distinguished guests, ladies and gentlemen. Eastern Mediterranean Middle East Climate and Atmosphere Research Center is a center of excellence within an institute of excellence, the Cyprus Institute. It is my privilege to thus invite to the podium the President of the Cyprus Institute, Professor Kostas Papanikolas.
Minister Kavis, Excellencies, and there are so many of you, it's really already a great omen and also sign of the burden that we undertake to deliver up to your expectations, clearly, which are great for a good reason, and we promise to deliver. It is with pleasure and pride that we welcome you here at the Cyprus Institute, launching here today this project of the Eastern Mediterranean Middle East Climate and Atmospheric Research Center. It's a regional, as the title already shows, regional project. It has to do with addressing one of the, not one, the problem of the 21st century, climate change in our region. And really, having so many representatives of countries of the region, I'm really glad to see that it is recognized as such by our partners here in Cyprus, and will pursue it as such. We take up the coordination of this extraordinary project with We undertake the coordination of this project with a sense of responsibility because we know it's a formidable task that lies ahead of us. Establishing a center of excellence, let's not call it a center of excellence yet, but we hope in a few years everybody else will call it a center of excellence, not us. We certainly will strive to develop an international center of excellence for research and innovation, for scientific, innovative, and policy making, providing policy tools to the policymakers which will help ameliorate the impacts of this menace that is going to face us, as Professor Leliveld indicated in the video that proceeded, for climate change in the region. It could not, these awards from the European Union could not have come at a better time, now that the entire planet is awakening up to the call that scientists have been saying for more than 20 years now, that actions to mitigate the climate change and tackle air pollution are indeed of paramount importance. The Cyprus Institute responded to this global demand early on. It was on our agenda from the very beginning of the formation of the Cyprus Institute, and we are well positioned to undertake this challenge. But particularly so now that the President of the Republic has initiated his own climate change regional initiative, calling all the governments of the Eastern Mediterranean and Middle East to rally, to form joint actions to address this point, coordinated from the government side by Professor Cadiz, who is with us today. The Cyprus Climate Initiative aims to develop a plan of tangible, real action for this region of the world, which is one of the recognized hotspots of climate change internationally. We at the Cyprus Institute have been given the responsibility, and it's a big one, to help in driving the scientific program together with scientists from all the countries of the region. And after we identify the scientific basis, the gaps, the knowns and the unknowns, work together with the government to provide a toolkit of policy actions that can be implemented locally and regionally with the coordination at the government level. This is really time for action, and action has to be based on science, and this is really now coming together, the scientific world and the policy world, as it should have been the case for many years ago. But it's never too late, and time for action is now. Aligned with this initiative mandated at the highest level, that of the President of the Republic, EMME-CARE must succeed, and it will succeed. It will succeed because we are determined, we, not meaning only the Cyprus Institute, but the world-class institutions that are partnering with us to do so, the Max Planck Institute, the University of Helsinki, and CEA from France, to establish this long-term program. It's a long-term program. It has a horizon of 15 years, and therefore we're not starting a road that will see the impacts in a year. This is here to stay for a long time, as is the problem, unfortunately, that we're trying to address. We are thankful to the European Union and the European Commission and the Cyprus government, since it's a matching fund arrangement, for the tremendous funding of this endeavor. We thank them for entrusting us with this challenge, and we pledge to do everything possible to succeed. We are confident that we'll succeed because the framework in which we operate goes even beyond the 4 partners that already I mentioned. I would like to recognize the leaders of these partners, Professor Markku Kulmala of the University of Helsinki, Professor Jos Lelyveld of our own, but the leader of the Max Planck Institute for Chemistry, and Professor Philippe Sies from the Laboratory of Climatological and Environmental Sciences at CEA in France. We at the Cyprus Institute will devote all our energy, all our efforts, and coordinate the actions in every other respect of the Institute, and it has, our other centers have a lot to contribute to this new center that is being established through this, either in cultural heritage, preservation of cultural heritage threatened by climate change, using the formidable computational powers that the Institute possesses to manage the huge amount of data, models that are needed to proceed, and so on. So, with this huge challenge lying in front of us, this is a historic day. It's the beginning. Next January, we'll establish a new research center, which will be organized around this theme. The project EMME-CARE is just a project, but the research center is the structure that will result out of this research program of the European Union, which will carry it from there on. The concept is superb. The global and regional demand is compelling, and we have every hope, with the help of the Cyprus government, the European Union, our partners, that will do the job. I will finish by thanking the colleagues here at the Cyprus Institute who devoted extraordinary effort for the last 4 years. This was a result this initiative started about 4 years ago. I would like to thank the director of the WRC and the director of the new center that will result, Professor Jean Siard. Jean, thank you very much. But also particularly Professor Jos Lelivert, who was with us way back from the establishment of the Institute with this vision of climate change research and how important it is to do so to advance the science vis-à-vis policy making. So I will not take more of your time. It's a great day for us. I hope in a few years we'll say it was a great day for Cyprus and the region to help in this big challenge. Thank you very much for honoring us today.
EMME-CARE is going to strive to become a center of excellence representing Cyprus and the excellence of Cyprus in environment, climate, and atmosphere. It is my honor to call to the podium the Honorable Minister for Agriculture, Rural Development and Environment, Professor Kostas Kadis.
Excellencies, distinguished guests, ladies and gentlemen, it is indeed with great pleasure that I'm here today to give a welcome speech at the Cyprus Institute to this very important event that marks the public launching of the Horizon 2020 teaming EMME-CARE, Eastern Mediterranean Middle East Climate and Atmosphere Research Center. And let me first welcome to Cyprus our distinguished guests from abroad. It's an honor for us to have them on board. I really thank them for their contribution to this great project. And of course, I wish them a pleasant and fruitful stay in our country. Our host today, the Cyprus Institute, coordinates this extraordinary project, which has a formidable challenge to establish a European Centre of Excellence for Climate and Atmospheric Research, a centre that will indeed conduct research of global excellence for and from one of our planet's climate change hotspots. However difficult the challenge, we are confident when we see the stakeholders involved in this project. The team of EMME-CARE is comprised of world-class leading research institutions and an impressive network of local and regional partners. The University of Helsinki in Finland, represented here today by a distinguished team and led by the director of the Center, Professor Marco Kulmala. The Laboratory of Climatic and Environmental Sciences of CEA in France, with a team led by Professor Philippe Sies. The Max Planck Institute of Chemistry in Germany, led by its director, Professor Jos Lelivert. Of course, I cannot highlight enough the great significance of the local and regional partners of EMME-CARE in academia and government. Their role is crucial in every aspect of the project, and particularly so in the areas of impact, policy, and innovation. As the Minister of Agriculture, Rural Development and Environment, I am also very happy with the involvement of several departments and units of my ministry. the Department of Environment, the Department of Forests, the Department of Meteorology, and the Agricultural Research Institute, represented here by their leaders and top scientists. We are proud that the European Commission has entrusted this strategic Horizon 2020 teaming project. We thank the European Commission for co-funding this great endeavor to the Climate and Atmosphere Research Centre of Excellence. We believe that EMME-CARE team will deliver to the expectations that will be presented here today by the honourable representatives of the European Commission. We are confident because we know the work of the Cyprus Institute, a novel research and educational institution with scientific and technological innovation orientation. The Ministry and the Republic have witnessed the Cyprus Institute's achievement in the field of climate change, emphasized by the appointment of its leader, academic and president of the Cyprus Institute, Professor Kostas Papanikolas, as the advisor of the President of the Republic on climate change and Presidential Special Envoy for Climate Change. As some of you may already know, at last World Summit in New York, we presented our important initiative on climate change, and as His Excellency the President Anastasiadis himself has worded, the Cyprus Climate Change Initiative aims at the development of a regional action plan to address the specific needs and challenges countries are facing in the Eastern Mediterranean and Middle Eastern region, to address and ameliorate the impact of climate change and advance mitigation actions. As Professor Papanikolas mentioned before, we are aiming to bring together the scientific community with the policymakers in order to develop this action plan that will be a toolkit with measures that are based on sound scientific data and will be suitable for the countries of our region. Our ministry is leading this initiative politically, and we stand shoulder to shoulder with those leading it scientifically, none other than the Cyprus Institute. We are very happy that our Cypriot research landscape attracted a French expert, Professor Zan Siar, with considerable international scientific and research experience and profile, who will lead the EMME-CARE team. We feel confident that the objective of the European Commission through the Horizon 2020 teaming programme will be fulfilled by EMME-CARE, and the Centre of Excellence will build on regional and international networks to lead scientific, research and innovation breakthroughs, provide advanced training and education, and establish infrastructure and globally recognized technical and scientific competences. Indeed, with such a centre, Cyprus will join other renowned European and world leaders in globally recognized science and research for climate change and our environment in full alignment with our government Cyprus Climate Change Initiative. Therefore, we look forward to the establishment and the operation of the Centre of Excellence, and on behalf of the government of the Republic of Cyprus, we will fully support it. Thank you all for your presence here today, and I wish you every success to this very important meeting. Thank you.
EMME-CARE will be a center of excellence representing the excellence of Europe. So it is my great pleasure to invite to the podium the representative of the European Commission and the Research Executive Agency, Mrs. Federica Rossi.
Good morning, ministers, ambassadors, distinguished guests, ladies and gentlemen. I feel very honored to represent the Research Executive Agency and also the European Commission here today. I would also like to bring the apologies of my colleagues from the European Commission who were not able to join us, but I will be representing them. And I'm very happy to be here at this opening ceremony of EMME-CARE project. It is in fact a historic moment for your institute, for your country, and in fact for Europe. And I'm very happy to be here and to share this important moment with you. Let me congratulate you on having succeeded in a very tough competition of 208 proposals, which were actually submitted for teaming 1. Then followed your work on the teaming phase 1, on the business plan, and then your teaming 2 proposal, successfully passing the evaluation. I was there for the evaluations, which also involved hearings, which is not very often that it happens within the European Commission to have such long evaluation procedures. So indeed it was complicated, and it's been a great achievement so far. So today we participate in the kick-off meeting of your project, and you are ready to embark on this exciting journey. I'm here on behalf of the Research Executive Agency and the European Commission, and the agency was actually set up by the European Commission in 2007. Its main mission is in fact to implement research programs. Projects under the management of the so-called RIA represent almost 20% of the Horizon 2020 budget. It is expected that the RIA budget share will be even more in the next framework program, Horizon Europe. RIA and the European Commission work closely together, and they are both very strongly committed to provide every necessary support in order to help your project to succeed. I have no doubt that all partners within the consortium will develop an excellent autonomous Centre of Excellence, and this is indeed our common goal. We, RIA and the European Commission, actually have high expectations from EMME-CARE, from the project, both in terms of implementation and in terms of impact. Impact not only in Cyprus, but at European level. We expect that the project will increase the science and innovation potential of your Centre of Excellence, which in turn will boost the science and innovation capacity of your country and provide opportunities for economic growth. In order to succeed and to achieve such an impact, and for the Centre of Excellence to be sustainable and have an autonomy in the long term, a strong commitment from all partners involved is very necessary. So you signed an agreement with the RIA, and we feel to be a part of this endeavour. We're very much looking forward to working with you, and we will follow closely the development of your project and we'll try to help make this journey and this project a success story. So regular and open communication with the project officer from the RIA, who is Miss Joanna Silva. Now, unfortunately, she's also not here today because she's sick. But we have Carla Rocha Gomes, who is sitting right at the front, who is our colleague and will be replacing her for these days. And she will be happy to help you with anything related to the project. So, as I was saying, communication is vital with the project officer at all stages of the process of the project lifetime. So, whatever happens, do not hesitate to turn to your project officer. She will be ready to help. I'm looking forward to listen and to learn more about your project during the kick-off meeting in these 2 days. And all that is left for me to say is thank you and good luck with the project.
EMME-CARE is going to be a Centre of Excellence driven by the dream and the vision of a scientist and a researcher. It is indeed with emotion that I would like to invite to the podium the EMME-CARE coordinator, Professor Jean Siach.
Good morning, everybody. It's really my pleasure to be here today. I've been working for so many years to have this day and to have the chance to present what we want to do, what we are dreaming of for the next couple of years on climate change, on air pollution. And finally, my dream came true, and I'm in front of you. I'm very proud, very happy to present what we would like to do, spreading excellence, widening participation. But before I present you EMME-CARE, I would like to say a bit more about our perception of what is climate change and air pollution. And this is a recent poll asking the European citizens what are the two most important issues facing the EU. Immigration is coming first, climate change is coming second, so it's a very important issue. But climate change is connected to everything, to all these issues, and also connected to immigration. And the World Bank indeed estimates that by 2050, there will be more than 150 million people migrating due to climate change in the world. If we still look about these threats that is facing the EU, the environment is also one of them, come as a sixth place. And if you dig a bit more and you want to understand what is behind the environment, then you realize that for European citizens, air pollution comes first as the environmental concern, much before everything else. So climate change is not just one thing, it's connected to everything, it's connected to air pollution. And I wanted to illustrate this by this table. It's a bit complicated, but the message is is that you have air pollutants, you have greenhouse gases, and some air pollutants are also greenhouse gases. You understand better why we have a climate and atmosphere research center. You cannot disconnect the two. Also, climate change will make air pollution worse. More dust, more fires, more smoke. A small graph here shows that CO2 is not the only player here in greenhouse gases. You have also some compounds which have a short time in the atmosphere, like ozone and black carbon, which are pollutants. So EMME-CARE is not just about climate, it's about climate and air pollution. Its goal is air pollution to establish a knowledge hub for air pollution and climate change research, aiming at sustainable solutions, addressing societal challenges for Cyprus and the region, Eastern Mediterranean and the Middle East. We don't start from scratch. In fact, we start from the Cyprus Institute Atmosphere and Climate Division, and through this project, Teaming 2, funded by Europe and Cyprus government, for a 7-year project started a month ago, with a budget of more than 45 million euro, create a new center of excellence, which will reach more than 100 staff, annual budget 5 million euro per year, with the support of 3 advanced partners, the CERA from France for greenhouse gases and carbon cycle modeling, University of Helsinki for aerosols, European Research Infrastructure, Max Planck Institute Germany for Earth System Chemistry Modeling. Our new center will interact with our regional partners. This is much needed for this topic, and support the government of Cyprus, public stakeholders, which is already our activities. Now, the outline of my presentation. I will tell you a bit more why we should care of the EMME, how we will take care of the region, what is our strategy, from where do we start, who will help us, what EMME-CARE will do for you. So let's start first with the region, why we should take care of this region. I go back again to this perception of climate change, and show here for different continents the perception of climate change as a very serious problem, harming people now, very concerned that climate change will harm me personally. And unfortunately, Middle East is the less concerned about climate change compared to the other regions in the world. This is very unfortunate because currently it's a climate change hotspot. And this is a study 15 years ago which was already highlighting that in the region, from 20 different models, it is a hotspot for climate change. with warmer sea surface temperature, also higher humidity that will enhance extreme events like floods. It's a hotspot for climate change. It's a hotspot also for air pollution. Satellite measurements of dust shows that it's a very dusty area. If you look at atmospheric dust in aerosols, compared to the other countries of the Mediterranean, it's one of the dustiest environments, Cyprus. Ozone is a hotspot. The region is a hotspot for ozone, for NO2, which is a pollutant emitted for combustion of fossil fuel. Hotspot of air pollution, hotspot of climate change, and the impact on health, of course. And this is illustrated here by different cities of Europe with the concentrations of pollutants of small particles in the air in microgram per cubic meter. And this is basically what you lose in terms of month of life living in these cities because of this air pollution. So basically, you are living in Bucharest, you will lose something like 2 years because you are not complying to the WHO air quality guideline. Now, if you put Cyprus in the map, Nicosia is unfortunately among the most polluted cities in Europe. This is not very obvious for Cypriots. They think that they are living far from strong emitters. It's a small city, it's not a mega city, but still, it is polluted, and living in Nicosia makes your life shorter by 1 year compared to the WHO guideline. So it's not something small. But if we want to go one step further and connect health impact to the economic cost, the European Environmental Agency, in its report of 2015, have highlighted that you have 8,000 years of life lost in Cyprus, mostly due to small particles. But if you translate this in terms of cost, you come up with $857 million of economic cost of death from air pollution in Cyprus, 3.3% of the GDP of Cyprus, which is 6 times more than what the government is spending for R&D, for comparison purposes. Okay, climate change is very bad. Air pollution is very bad in the region. Unfortunately, it will be worse in the future. This is climate projections by the team of Jos Lallefeld at the Cyprus Institute, showing that by the end of the century, 4 to 6 degrees more in the region compared to the current state. It will be warmer, it will be drier, much less precipitation during the rainy period of the winter by the end of the century. Dust will get also higher. This is measurements of the concentrations of dust above the region for the last 15 years. Showing what? Showing a hotspot that was not existing before, above Syria, above Iraq, linked to probably migrations of people and desertification in the region. But this region is very close to Cyprus. Growing desert next to us brings a lot of dust, like this episode we got in 2015, which is the century event, where we got 100 times more than the European limit in terms of pollutions due to dust. And this is expected to continue and be even more. Population will grow also, and this population will emit even more. This is the population around the Mediterranean, and the color code shows that the countries in Asia and Africa will have a population growth that is much more important than in Europe. And if you compare the fraction of population per continent in the Mediterranean, you see that in Europe, in 1950, 2/3 of the population of the Mediterranean was the European population. By 2050, 2/3 will be from Africa and Asia. Completely changed. So the Mediterranean population is going currently a very high anthropogenic pressure, almost 500 million inhabitants living in our region. And this pressure is very specific because will be more and more of North Africa and the Middle East, regions that do not have to comply with the European regulations in terms of emissions. So this makes the situation even worse. Regional CO2 will go also higher, unfortunately. And we are in a hotspot in terms of CO2 emissions. This is annual emissions for each country. And if you look at the trends, this is the European Union emissions of CO2. And this is the Middle East. We stopped in 2015, but within the next few years, by probably 1 or 2, 3 years from now, Middle East will emit much more CO2 than the European Union, an increasing trend. So situation also will get worse in the region in terms of CO2 emissions. So I hope I convince you that we should really care of the region. Now, how we will do it? Well, we have currently a challenge in the region that we are missing some observations. This is the data that is used to predict climate change, global atmospheric watch of the WMO. This is all the stations in the region, and this is the same stations, but those who are reporting data, which are reporting data. So we have a lot of stations. The coverage is okay, but when you ask countries to report their data, they don't. So we have no information in the region. Look, it's an empty area here. It's a problem to predict the climate change in the region if you don't have data. Now, if you look at another network that is used to constrain the climate models, it's measuring the concentration of aerosols in the air. Look in a network when you ask 1 year data. It's an open access, so it's available for the entire community. But if you want to see trends, and it's very important trends, 5 years, 10 years, this is the only data we get for 10 years observation. Obviously not enough. How we can address climate change trends if we don't have long-term observations? These are the challenges we want to tackle for EMME-CARE. Now, if you look at more specifically European networks of greenhouse gases, ICOS, currently well developed, but missing in the region. Aerosol class relative gases, not very well developed. Remote sensing, nothing. Solar radiation, nothing. We are missing critical information about the environment to better predict the climate change in the region. Now, what is our strategy for the region? We will build an integrated Earth observation system with satellite observation, ground-based, UAVs, in situ, and simulation. Our partners will help us to establish these observations, and even more important, we will connect this observation to all these international networks that currently provide high-quality environmental observations that are needed to predict better what will be the climate change in the future. So EMME-CARE will fill the gap of observations for better prediction of the impacts in order to support national mitigation and adaptation policies with innovative solutions. How we will do it? We will observe and fill the gaps of observations in the region that will fill models that will simulate weather extremes, climate change, water cycle, dust, air pollution, which is needed if you want to address regional impacts related to health, water resources, ecosystems, renewable energy. What is our strategy here? We will create a fourth research center of the Cyprus Institute, CARE-C Climate and Atmosphere Research Center. Will be governed by an internationally acclaimed board composed by the partners of our consortium and faculty from the region. CARE-C will also be supported by a scientific expert panel chaired by Dr. Michel Jarraud, who gave a very inspiring talk yesterday evening, Secretary General Emeritus of WMO. We will establish a headquarters for us. We are here, and we will build, not far from here, a new building with capacity of more than 100 staff, 1,000 square meter research labs, large auditorium, permanent exhibition hall that is very important for dissemination public awareness, networking, guest rooms, air quality observatory for training platform, innovation with incubator for spin-off companies. We will build one of the largest environmental stations in Europe, in the top 5, in Peia, west of Cyprus, from a donation by former President Vassiliou, to establish one of the largest environmental station in the Eastern Mediterranean and the Middle East. This is much needed for us. Greenhouse gases emissions come from different sectors. You know that. It comes from electricity production, agriculture, industry, transport, building. So basically, when you want to tackle climate change, you realize that you tackle a lot of vertical priorities of the smart specialization strategy of Cyprus: agriculture, bioenvironment, health, transport, energy, environment. We are also addressing out of 17 sustainable development goals, with, of course, climate action being the most important. From where do we start? We don't start from scratch. we are a young institute which has established in 2007 the Energy, Environment, Water Research Center, a year after the Atmosphere and Climate Division was established, following a successful ERC obtained on climate change by Professor Jos Lellefeld. And then we continue to develop with a doctoral program, with a master program, and by 1st January next year, a new center on climate and atmosphere. Our KPIs, we are currently bringing more than €1 million per year of competitive funds from Europe, from Cyprus, currently 16 research active projects. We are already working on atmosphere, we are already working on climate change. I'm very proud to say that we are already 52 and 10 different nationalities within our division, that we are already publishing more than 50 papers in top journals, 5 active research laboratories. Our center, Climate and Atmosphere Research Center, will be established as 1st of January 2020. But we have already the structure in place with everybody working inside. We are already operational from day one for research and innovation departments, facility support. We are proud also to have developed recently a research and development affiliation program with a lot of affiliated staff already working with us. We will enhance it with bringing more regional partners. 13 affiliated from 6 different countries, 8 faculty, 5 researchers. Atmospheric observations, we have already started 5 years ago. With what? With one of the 17 stations of the European Research Infrastructure Actrice, which is established here in the center of the island at Aia Marina Xeliatu, part already of a lot of international networks. Also, air quality in cities with our recently established observatory here in the campus of Nicosia, of Athalassa. Validation, calibration of greenhouse gases satellite observation, collaboration with the University of Bremen, already with measurements that are completely missing here to validate the satellite that measure CO2 above the region. Supercomputer that was already mentioned, one of the largest supercomputer in the region, the biggest one in Cyprus, that will support all this data management, all this repository, all these prediction models that we will be performing in EMME-CARE. Facilities for chemical analysis with instruments that are dedicated to environmental atmospheric measurements. Something that is quite unique, a private runway and airspace to monitor the atmosphere above Cyprus with a large fleet of drones that will bring innovation in our research. We will not do it alone. Who will help us? This environmental climate research, national regional networking, will be supported by CEA, France, for research and innovation, University of Helsinki for education and research infrastructure, Max Planck Institute for fundamental and applied science. CEA is the world leader of innovation from research to industry, very large, 20,000 employees in France, major contributor to research and innovation, serving state, industry, society, open and working with decision makers and citizens. The fundamental research division of CEA has 7 institutes in which LSE, the Climate and Environmental Laboratory, which is our partner for EMME-CARE, with very impressive KPIs in terms of scientific excellence, open dynamics, active innovation. The University of Helsinki, and in particular the Institute for Atmospheric and Earth System Research, is our second partner of EMME-CARE. It has almost 350 staff, similar to LSE, funding of €40 million per year of research, and again, very impressive key performance indicators in terms of science, with huge number of ERC grants, nature science publications. Eco-innovation cluster also developed in Finland, and probably the largest in Europe, or maybe even in the world, environmental station to monitor in Finland more than 1,200 different variables. It's a huge number of data, big data. But this is much needed to understand the different interactions between climate, atmosphere, biosphere, ecosystem, and so on. The third partner, Max Planck Institute for Chemistry, has 100 years of scientific history. And more recently, on atmospheric and biogeochemistry with Nobel Prize, 1995, Paul Crussen on the ozone layer. It has 4 different departments, again 300 staff. It's interesting to know that our three partners have roughly the same number of staff, 300. And with topics that are fully aligned with EMME-CARE, atmosphere, biosphere, ocean, climate, health. We will not work alone also in the region. We will leverage the strategic location of Cyprus, being a European Union member state, island of the Mediterranean, located in the Middle East, connecting our advanced partners to our regional collaborators. We will bring to the region European research infrastructure that is already developed in Europe. We will collaborate and bring also use European funds to develop research in the region. And in the region, we will connect regional nodes, Future Earth, MEDACordex, MEDEX, and regional collaborators to this dynamic. Finally, what EMME-CARE will do for you. Over the island, one of the first goals of EMME-CARE is to support the government of the Republic of Cyprus by the provision of technical studies, supporting their policies. We will, of course, enhance our collaboration with the academic network. We will disseminate network through associations and NGOs, and perform innovative projects with private stakeholders. Where we are already doing it, it's not just good wishes. I just want to illustrate it with a few activities we are doing for many years already, providing high-quality environmental analysis of air pollutants in collaboration with the Department of Labor Inspection for regulation on air quality. The same with the Department of Environment, reporting greenhouse gas national emissions. And more recently, developing cost-effective UAV solutions for forest fire monitoring. We are already supporting the government of Cyprus. This is a mission of the Cyprus Institute. And we will enhance this support. We will also provide to the society forecasting products to better adapt to air pollution, to climate change, with prediction in terms of mineral dust, air quality forecasting, and even pollen alert platform in Nicosia. We will train and educate the next generation of scientists, because climate change will not stop, you see. We need to be prepared. We need to have scientists of the next generation to continue our big efforts through our doctoral program that will be enhanced with our advanced partners, master program, and key features of them. As usual, we are very proud that our language instruction is English, that our education is directly linked to our research. This will be a key player for EMME-CARE. Highly selective, small number of students, and dual doctoral degrees with top university of Europe. My last slides will also highlight how much we want to promote public awareness. That is very important for climate change. And I will illustrate this by this conference that was mentioned before, what we organized in 2018, where we managed to gather the chair of the COP21 Paris Agreement, Laurent Fabius, former Prime Minister of France, Jeffrey Sachs, Chief of UNSDSN, Stylianidis for European Commission, Talas for WMO, 350 participants, 20 countries. We want to do more. We will have a second climate change conference next year. We will do it every 2 years. Attract even more people, more countries, more collaboration that will, in the end, help EMME-CARE. Thanks for your attention.
Your Excellencies, distinguished guests, ladies and gentlemen, we would like to sincerely and warmly thank you for honoring us with your presence in the ceremonial part of our launching event. We will commence again at 10:45 with our interesting scientific and research talks from our advanced partners. You are all now cordially invited in the foyer for refreshments and coffee. Sincere thanks once again.
Καλημέρα, καλημέρα.
Θα ήταν εύκολο να μπορέσετε να την παρουσίαση του κύριου Σιάρ.
Βεβαίως, να ρωτήσω τον ίδιο και να...
Βέβαια, ναι, είμαι εκπρόσωπος της ελληνικής πρεσβείας.
Έχετε κάποιο... Γεια σας. Ελληνιπικός.
Σας κατάλαβα που προφορά την
Ναι.
Να σας πω...
Μπορώ να σας τη στείλω.
Είναι πολύ βαρύ το αρχείο. Μπορώ να το πάρω τώρα.
Αν έχετε φλασάκι...
Για να είστε εντάξει, δεν πειράζει.
Να σας πω, δεν έχει κάτι presentation μέσα. Θα σας το δώσω πώς θα την ενημερώσω. Τώρα να τον... Βάλτε το φλασάκι σας εσείς. Να βεβαιωθώ ότι είναι...
Γιατί ξέρω ότι με email δεν θα μου φτάσει. Ξέρω αυτό.
Ναι.
Τι θα έχετε στο Ινστιτούτο.
Είμαι ο κεντρικός διαχειριστής του νέου κέντρου.
Τι ωραία.
Να είστε καλά.
Ποιο νέο κέντρο, του EMME-CARE.
Αυτό, ναι.
Αυτό που ιδρύθηκε τον Σεπτέμβριο, κατάλαβα.
Σωστό. Τώρα να δω ότι είστε εσύ. Ναι. Λοιπόν, δώστε μου μερικά δευτερόλεπτα να τακτοποιήσω και τους υπόλοιπους ομιλητές που είναι να το coffee break. Ρωτώ τον κύριο Σιάρ και σας βρίσκω. Πάρτε έναν καφέ. Ναι. Το όνομα σας.
Σοφία Κουκούνια.
Εντάξει κύριε Κουκούνια. Θα σας βρω έξω. Έκανα φάουλ. Με σένα. Δεν είπα το όνομά σου.
Και σιγάρε, Παναγία, με να βγάλεις τον προνόστο κάτω.
It's about my presentation.
Yes.
I have changed it a little bit.
Okay.
I still send you the new version. We can go so this one. You received it before. I sent it to Jean, you, 5 days ago. Just wanted to make sure for the next
So you don't have it in USB now with you? Do you have the new version with USB?
I have my computer, but it's a new USB, USB-C key. And I'm not sure I have a key with me.
Voila.
Not this one.
You want the other one?
The other one.
Let me see if...
But otherwise, if you already have the old one here,
I have to download it anyway. So if it's a matter of
maybe I can
download...
just send it to you. Your email is
Yes, but maybe I should ask. Thalia, can you help Professor CS with his presentation? He needs to send it to you a new version. And then you bring it to me with the USB.
Okay, so I will send you
I think it's better.
Okay,
We have a lot of time, it's 10:45.
I know you are busy.
Yeah. Μάλλον σε λίγο να τα σηκώσω. Σήμερα, ναι. Θα μιλήσουμε και για το άλλο θέμα, γιατί είχαμε και παρουσία χθες το βράδυ. Να ανοιχτά και τα μικρόφωνα, ναι. Θα το μιλήσουμε. Έχουν ασκηθεί κάποιες πιέσεις. Τώρα να δούμε. Είδαμε, ναι, μου είπε και ο Αλέξης. Είδαμε. Εντάξει, είναι χαζομάρα, αλλά... This is the original list that is, he got sick and he didn't come. Okay? Same order. Είσαι καλά? Νίκος Μαρδάς. Σε γνώρισα από το... Καλά, καλά. Ευχαριστώ πολύ. Καλά είναι, ναι. Είπα και το πυροσβεστικής. So we don't change computers at the...
Is this a bit of a powerful computer?
Let's see, it should be. But let's test it now. If we don't like it, so which one is it? EMME-CARE Lelefe?
Made backups here, EMME-CARE.
So which one?
This is the
third.
The third.
Copy. Paste.
What I would do is also copy this one, the EMME-CARE results, because that's the video.
Okay. It's more relaxed now. We will not have ambassadors, etc. Or even if we do, it's more relaxed. So it's okay if we spend a few seconds. Now, let's eject it anyway. Okay. And now let's test it. All the slides have downloaded. And the video is this one?
Now I need to go to this one.
And then play okay.
Then go to this.
Let's go to up. So it's this
Next
one. We go to the next one.
And
And
video.
then
Press again.
left, sorry.
Yeah, it works.
Does it have sound?
No.
Okay, perfect.
I'm going to shut off this bit of
Use,
light.
use, don't that. You don't have to worry. I will. Thank you, Professor. Πες το αδερφέ.
Όταν λένε tour στο σταθμό, εννοούν εδώ, στο CYI το container, ή θα πάνε μόνο.
Τι ώρα?
Σήμερα, 1:30.
Στις 2:30, ναι.
Πάνε και container εδώ, εδώ στο container.
Κοντέινερ εδώ. Μετά έχει αγέμα την εξηλιά του.
Ξέρω, για να ξέρω άμα ήταν από την κατευθείαν.
Όχι, είναι
Εδώ, στο everywhere.
You have presentations from yours, Philip?
I'm looking at that. It's everything under control.
She's making fun of me.
So I gave my presentation to Talia.
It's already there. Whatever you gave to her, it's there. I will take the blame, but it's you that brought it to
So
me.
they have been asking for photos of people and they did not reply. So finally I did what I could, but I prolonged something.
It's going to be more relaxed. I expect most of the ambassadors will be also the minister of Baraka, for which she will be late. Yes. More assurance. No messages. Perfect. And what is the time? You can become a scientist now. Enough politics. Let me do the politics. Jean. Jean. Chef.
Ladies and gentlemen, dear friends, please slowly take your seats again. We will start in 2 minutes. In 2 minutes, thank you.
Έλατε. Έλατε.
Dear friends, please take your seats. We will start in 1 minute. There is also seats in the front if someone wishes to move forward.
Προσωπική επιλογή. Παρακολουθείτε λίγο.
So, Excellencies, dear guests, welcome back. We are now starting the scientific and research part of our launching. The Eastern Mediterranean Middle East Climate and Atmosphere Research Center will be facing several challenges, but will also leverage several opportunities. To elaborate on challenges and opportunities for atmospheric sciences and research infrastructure, please welcome, on behalf of our advanced partner, the University of Helsinki, and on behalf of Professor Kulmala, Dr. Lubna Dada.
Good morning, everybody, ladies and gentlemen, Your Excellency, dear partners. I will present to you the challenges and opportunities for the EMME-CARE region. So, the globe is on fire. We don't have our basic human rights, like fresh water, fresh air, and so many other things. We're going into deteriorating energy consumption and ocean acidification and so many others. And there are two urgent global challenges, which are climate change and air pollution, which might not seem to be so drastic at the moment, but they are for sure will be something really extreme in the coming years. So, first, we also have this global energy challenge, where we can see the increased consumption of energy, where in the EMME region, there is the most use of fossil fuels, especially in the warm season, where the demand of air conditioning increases. And all of this is mainly triggered by the increase of population, which is expected to reach in 2035 up to 9 billion people. And we know that the increased population in the EMME region is actually huge. Besides the global energy challenge, we have the CO2 challenge, which doesn't seem to subside. It's in constant increase, constant demand, and then so much CO2 is emitted, and we don't seem to find a solution, although we are in the 21st century. And then we have the radiative forcing uncertainty challenge, which we also aim to address, where we are actually uncertain about so many things because we address each of those individually. And specifically for the EMME region, besides this 1 to 6 degrees increase, we have extreme weather conditions. You can ask anybody who grew up in this region about these extreme weather conditions. Like when we were kids, we didn't feel that it was too hot in summers, or the sudden rain that we get for very short times in winter. We have a decrease in the annual rainfall, and we have increased dust storms, and especially here where we are exposed to both of the largest deserts. There is clouds of toxic ozone smoke, and there's change in the terrestrial and marine ecosystem, and so many other challenges in this area. And indeed, the air pollution research activities in the area are quite limited, especially in the Arab countries, which have not been given enough attention. And less than 20% of these studies is actually suitable for policy making. The Middle East and the North African region has been under fast development and urbanization and increased population. So we looked at what sources of air pollution there are in the EMME region, and we found out that actually 52 are of natural soil dust and sea salt. But how do we aim to address these challenges? Is first, we need to look for an integrated approach and try to deal with these uncertainties first in an integrated approach. So instead of dealing with each of those independently, we need to find a way to combine all of these in order to understand the feedbacks related to them, in order to decrease the uncertainties, and to mitigate and adapt effectively. So how to do that? We need multidimensional, multidisciplinary, multi-scale approach to answer these climate challenges. So we need to start from the ground-based measurements or any other type of detailed measurement. It can be ambient, it can be chamber, and then we need satellite measurements, which give us context. And at the end, we need models so we can complete the picture. So we need clear and ambitious vision, we need practical solutions, empirical measurements and modeling. So we need to go from research to innovation in order to look into the economic growth and the human well-being. So we will now give you an example from our 20+ experience in research infrastructure. Not myself, I was barely a kid 20 years ago, but the University of Helsinki approach. So Marco published this paper in 2018, and it's the answer to all the global challenges is to have a global Earth observatory with 1,000 or more well-equipped ground stations so that we can measure to know what we have so that we can address or solve or look after. So this journey started at Smir 2 station, which is a boreal forest in the countryside in southern Finland, and it consists of a mast. If Marco was here, he would ask you to raise your hands if you have been to Hytjala. So very few people, but you are all welcome to go there. There is a 125-meter mast here, which has measurements of very different variables related to meteorology, ecosystems, and other stuff. We have aerosol measurement, and here there are a couple of saunas by the lake where we also have measurements on the surface of the lake. So this station actually has continuous comprehensive observations, and it has big data for more than 20 years. And if we combine all these data sets, we will have more than 1 to the 10 data points. And it's a site to study the lake, the forest, the peatland, from the atmosphere and the soil, and the whole ecosystem relationship from different sources of, let's say, pollutants. This is how it looks like if we take a close look. So forest with Scott pine belts, here's the tower, the cottage. Here is an example of measurement, ambient measurement from the tree. So this is a chamber, and this is pine leaves inside where we actually do measurements directly emitted from the tree. So why is it important to have this really robust, comprehensive measurement? It's because we will understand the trends, exactly what Professor Jean-Siard said. How are we able to address something if we don't have measurement trends? How can we address the future if we don't know our past, and so on? So we need to have trend in the measured concentration of actually everything that we have to understand the processes and the feedbacks from also everything. Like we are here in the EMME region, we have the ocean, we have the air, we have the deserts, and there is ecosystem also involved in all of this. So the journey started actually at Smear 2 station, where we discovered the world below 3 nanometer. So what is happening here? What is the chemistry and the biochemistry and the nanoscience behind these very, very, very small particles, which are below 3 nanometer in size? So we have collected different instruments that were able to measure those, such as mass spectrometers, to measure the chemistry, the particle size magnifier, which equips the particle counters, and then the bigger particles. So what we observed is that these very small particles are actually able to affect the cloud condensation nuclei, and directly and indirectly thus affecting the climate. From our recent study also, we were able to find that these very small sub-3 nanometer particles are able to grow further to large enough sizes where they are able to contribute to haze or pollution in megacities in particle sizes that are around 1 micron to even 2 micrometer in diameter. But we need to also understand that different places have different environments, and in order to understand the whole process, we need to look at the chemistry of these smaller particles so that we know where they come from. So we started with the boreal forest environment, and here we show the molecular composition of the particles in this boreal forest Hytiala, where I showed you the pictures, and we found out that the smallest particles in the boreal forest are composed of sulfuric acid and organics. So the necessity of having a mass spectrometer or multiple mass spectrometers is shown here. So this is the boreal forest environment, and this is the high altitude environment, and we see that it's mostly highly oxygenated molecules together with sulfuric acid and ammonia, which are similar to the boreal forest environment, but in different fractions, let's say. If we go to the marine environment, we see that actually the composition is far from organics and far from sulfuric acid and ammonia, and it's rather iodic acid. We went to Antarctica also and realized that it's sulfuric acid ammonia nucleation, or these small particles have molecular composition of sulfuric acid and ammonia, and they don't have organics in their composition. And then we went to Beijing, actually this is Shanghai, and we found that there is more than just ammonia participating in the formation of these very small particles, but rather it is dimethylamine, which is another base species. Indeed, after all of that, and once this study has ended, we started a measurement in the dusty environment in Saudi Arabia, and this is a very recent publication where we found out that there is really high particle number in the biggest sizes, and that there is new particle formation, which is the observation of sub-3 nanometer particles in the atmosphere out of just gas to particle formation, 73% of the days. So in this Saudi area, we found that on 73% of the days, there is sub-3 nanometer particles that are formed from gases that grow and could participate to air pollution. However, unfortunately, because we don't have any mass spectrometers in this area, we couldn't identify the molecular composition. So we didn't know. We don't know what the sources are. We cannot do any policy here because we don't know where these particles are coming from. So this is why having a smear concept and a global comprehensive feedback analysis is important. So we need to know what we have, to know what we solve. This is an example from our measurement station, or the boreal forest, where we show that the increase in photosynthesis increases the volatile organic compounds, which in turn increases the cloud condensation nuclei, and in turn increases the radiation, and so on. This is a feedback loop, which could be a start of what we want to study in this area here. However, we need to keep in mind that these feedbacks are not always linear. For example, this is an example from Nanjing, from the SORPES station in Nanjing, where we see that after doing NOx control, NOx comes usually from traffic, that when they did NOx control, they caused an increase in ozone, which in turn increased the PM 2.5, so the particle number concentration. So things are not linear, and in order to have a complete picture, we need to be measuring everything at the same time. So if we were only controlling NOx and CO in this case, we wouldn't have known that this is the trigger actually for the PM 2.5. So what we need is a clear and ambitious vision from deep understanding to practical solution. We need to have networks, stakeholders, and we need to have a multidisciplinary research infrastructure concept, which is actually in the room here. If we look at ourselves, we are young researchers, senior researchers, we are students, we are policymakers, we are representatives, and we are able to make a change if we combine all our knowledge in this huge picture. So our vision is to have 100 smear stations around the world or around the area where we can combine these observations from the several points. So we need a world-class research infrastructure integrated network, and we need to have partners. So we need to be part of the bigger networks which have long-term observations of different things like aerosols, trace gases, ecosystem, and so on, so that we are able to combine the observations and make a statement. We need excellent science, education and training, innovations, and we need to also address the public, the society with what we know, and the public should return this to us by believing the science that we are doing. So it's a two-way thing. And also, we need to have policy dialogue. So exactly what we have here. So we are scientists, we tell you what we know, we do measurements, we combine them, we talk to each other from different countries, different backgrounds, different disciplines, and then we combine these observations and take them to the policymakers who are actually the actual ones who are doing the change and putting the implementations in practice. So here there's an example about what we're starting to do in ENR in this region. So we had these lead initiatives of Global Smear and the Silk Road, which combines China and Finland. So this is an example what could happen here. So in specific for the EMME-CARE region, we need at least one smear-type flag station, which is already in practice and on paper what will happen next. We need integration, scientific impact, hierarchy. We need the countries to talk, the scientists to talk from different disciplines, and we need open access to all of these data. Exactly what Professor Jean-Siard showed, that if there is no sharing of the data, we cannot complete the picture. So, and of course, the education and the knowledge transfer is one very important aspect which will be addressed in work package 4 tomorrow. So the main messages of this is that we need continuous measurements to solve the grand challenges and the problems. So the campaigns are not enough. We need longer-term measurements. We need to collect trends. We need global smear stations to also connect the bigger picture. The integration, we need longer data. We need to keep in mind that the very small, tiny particles actually matter. So in the future, we will combine the smear concept, the health, and the socioeconomic in this project. Thank you. Yes.
Thank you, Dr. Dada. Now, to elaborate on challenges and opportunities of EMME-CARE for greenhouse gases and predictions, please welcome, on behalf of our advanced partner, the French Commission for Atomic Energy and Alternative Energies, Professor Philippe Siès.
Thank you very much. I must say that it's pretty emotional to see everything that has been done by Professor Jean-Siard and colleagues from the Cyprus Institute for the success of this project. In terms of greenhouse gases, the Paris Agreement represents perhaps the only way for humanity to avoid, or at least to minimize, the most dangerous impact of climate change. It's a challenge in terms of the effort of emission mitigation that will be required. It's also a challenge in terms of the information that the United Nations will need to ensure that the world is on track. Because insofar, only developed countries, part of the so-called Annex 1, are providing regular estimates of their greenhouse gas emissions based on energy production and consumption data. But now, in the Paris Agreement, all the countries of the world will have this requirement to supply data every 2 years, and many countries do not have yet the infrastructure or the methodologies to do that. I should also stress that in the end, it's not only the national budgets that will be regularly aggregated and looked upon in the global stocktake, which the next one will take place in 2023, but also there are a lot of voluntary emission reduction projects at the scale of regions, cities, industrial areas, and also many companies, factories, and power plants. Like in Europe, the ETS power plants are subject to regular reporting of their activities and emissions data. So starting at the global scale, the global scale is convenient because CO2 and methane are long-lived greenhouse gases. So in the end, the amount of emissions produced by human activities minus the amount absorbed by nature should match a very well-observed quantity, which is the annual growth rate of CO2, methane, or N2O. Together with the Global Carbon Project, we provide an update of the global carbon budget, looking at national statistics, but also international database from the International Energy Agency, BP statistics, and CDIAC for fossil fuel emissions. We used satellite information and models to estimate emissions from land use change. And now, since 2 years, in the paper produced by Corinne Lequeré, we estimate the land absorption of carbon dioxide and the ocean absorption using models. So, of course, the sum of emission and model sinks do not match the atmospheric increase because there are uncertainties in the way we quantify and understand the natural sinks, and we try hard to reduce this annual imbalance between bottom-up models and the top-down constraints. Our institute plays a large role in this effort. We also lead the global methane budget, which is not coming up every year, but every 2 years. It's led by Marielle Saunois, and the new update of the methane sources and sinks. It's a more complicated problem than carbon dioxide because there are many different source types, natural and anthropogenic, will appear this year. The
GCP is also now developing a global N2O budget, and the paper is submitted and will appear next year. And we keep the Global Carbon Atlas, which is funded by a donation from the BNP Paribas Foundation that provide to the public and to the policymakers all the numbers on annually updated carbon dioxide emissions. You may want to ask what is the outreach, what is the impact of this work, which is, of course, a highly collaborative work. More than 53 research organizations in different countries contribute to it. When you take the media coverage of the annual budget, which is released every year, about around December 4, at the COP Times, it's picked up by all the major newspapers. And if you look at the audience of all these media, which potentially, of course, doesn't mean that everyone is looking into the Carbon Atlas, more than 2 billion of people. So it's a huge outreach, it's a huge impact that we have by providing this annual science-based synthesis of the global greenhouse gas budgets. Now back to the Paris Agreement. We know that to limit climate warming to below 2 degrees will require a Herculean effort to reduce emissions in the next century. Emissions have been increasing over the last decade at a rather fast rate, about 2% per year. And if we want to stay below 2 degrees, emissions have to first stabilize and then to decrease very steeply in the next decades. It's about a cut by a factor of 2 every 10 years, which is very big. It's a decarbonization rate for the global economy of 7% per year. If you compare that to historical decarbonization rates that were achieved in some countries like Sweden or the UK in the past, it's never higher than 4%, and only the electricity production system was decarbonized. And this may not be even sufficient, so that most of the integrated assessment model scenarios that try to make emission profiles, they also call in by the end of the century for negative emission technologies that will have to capture CO2 from the atmosphere to maintain a concentration that is consistent with low climate warming. This is already a challenge in terms of how we are going to monitor the efforts of the different countries, knowing that, as I said, many countries do not have accurate reporting systems, because we will be, from now to 2030, during the successive stocktakes, entering into, hopefully, a trajectory of emissions that will be different from the one we had before. And it's very important to have systems that can both establish baselines for the amount of greenhouse gases emitted by each country, and also will have the capability to monitor emission trends. This capability is not yet here, so that they may be, divergent, and it's important that we pick up any, let's say, divergent from the trajectory using better inventories, better counting of carbon, but also, as I will show next, there is a hope to use atmospheric observations to strengthen this system. Emissions in the EMME-CARE countries are very significant. Here you have 2 major economies, France and the UK. Emissions have been stable and reduced a bit recently. If you compare that with those from Iran and Saudi Arabia, you can see that today the individual annual emissions of Iran and Saudi Arabia are about 1/3 higher than those from France or the UK, and Egypt is catching up. The emissions of Turkey is equal to the one of the UK as per the last year. So the trend of emissions is very strong, and the total of emissions is very big in the EMME-CARE regions. So what we can do with the atmosphere is that we can make measurements of carbon dioxide in the concentration in the atmosphere. If you take measurements, let's say, upwind and downwind of unemitting regions, you can apply what is called inverse modeling to deduce the surface sources and sinks that are consistent with the time variable 3-dimensional concentration field. This approach is already used to quantify fluxes at the global and the continental scale, but it's quite a challenge to use the atmosphere for smaller scales because, as Jean-Sia explained in his presentation, we lack dense observations in the regions of interest. The take-home message is that the atmosphere has superpowers. It has, in fact, the powers of being a mathematical integration of the surface fluxes, but to enable this power, we do need a dense sampling of the atmosphere. And because the in-situ network that was shown before for aerosols is not developing very fast, the idea has been to use remote sensing of the total column concentration of CO2 to have more data, in particular over the areas like the tropics or the Middle East or the high latitudes, which are not covered yet by dense observations. The principle is to measure the differential absorption of carbon dioxide or greenhouse gases from the sunlight in the shortwave infrared spectrum that is reflected on the Earth's surface. It can be also reflected by aerosols in the atmosphere, which is sampled by high-resolution spectrometers. And here you can see the different spectra corresponding to the absorption bands of carbon dioxide. So you need models to transform these satellite radiances into concentrations. You need first radiative transfer models that describe the state of the atmosphere and will provide concentration fields. And then you need atmospheric inversion model to interpret this concentration variability into fields of emissions. Europe has been very prominent and very active in fostering global observations of carbon dioxide from space. In the new plan of the Commission, there is one particular Copernicus initiative which is mentioned prominently. It is the Copernicus CO2 initiative, which is led by ESA and the European Commission, and it consists of flying a constellation of 4 imagers. Imagers are particularly important to sample emissions around the world that should allow about a daily coverage of the world. Of course, you have clouds, and when you have clouds, no data will be available. The strategy we would like to develop with our partners from the Cyprus Institute and LSE and others in EMME-CARE is in fact not only to focus on carbon dioxide, but to use co-emitted species, because most of the combustion processes also emit nitrogen oxide, sulfur dioxide, and carbon monoxide that are actually today monitored by satellite imagers, and to establish EMME-CARE as a very strong regional emission modeling and analysis center that could provide annual analysis of greenhouse gas and pollutant emissions in order to support regional stakeholders and inventory agencies. A focus can also be placed on the emissions of megacities and industrial sites, and we hope that it will foster a very strong input of the Cyprus and a very strong participation of the Cyprus Institute into the Copernicus program. This image shows a picture of the Earth, the first picture of the Earth taken by astronauts from the Apollo mission on the left. And the picture on the right is a model result. It is a cloud that was simulated by the ECNWF at that time. And you can see that the numerical weather prediction community, which is also assimilating meteorological satellite and in situ data for weather, has reached a very high level of accuracy in modeling the atmosphere. In particular, what is important for emissions, the atmospheric transport fields. The two pictures look extraordinarily similar, considering that the image was taken in 1972. So what we plan to do in EMME-CARE is to develop a high-resolution inverse modeling system based on the experience we had over Western Europe at LSE, covering the entire domain. And this system that will be reconfigured for the EMME-CARE region will make use of carbon monoxide, nitrous oxide, and sulfur dioxide, as well as the new CO2 observations that will be available in the coming years. Yet, satellite data need to be very accurate, and they need to be evaluated against ground-based observations. I would think that nothing can replace the high accuracy of high precision in situ data on the ground. First of all, because they are in the boundary layer, so they are more sensitive to the signal of emissions and things. Secondly, they can operate during all weather conditions, including during cloudy periods. And in Europe, thanks to the ICOS research infrastructure, we do have a dense network of stations that allows to track emissions and things in Northern and Central Europe. But as Jean-Pierre noticed in his presentation, there is a wide gap in the network in the Eastern Mediterranean and Middle East area. Our institute is in charge in ICOS of running the thematic center. The missions of the Atmospheric Thematic Center is to calibrate and test and improve high precision gas analyzer for greenhouse gases, to operate a central database and to serve data to the scientific community. Not only research users, but we provide on a daily basis to the European Center near real-time data from all the ICOS stations that they use in their Copernicus model system. So the vision for EMME-CARE is to start, of course, from Cyprus to develop a very strong regional hub associated with a high-precision observatory of greenhouse gases, and then perhaps to team up with associate universities and scholar institutions that are already collaborating with Cyprus to surround the area with atmospheric CO2 stations. We already have a gas analyzer running in the city of Athens today, and progressively to fill the gap in the region by adding high-precision stations that will transmit data and provide help to quantify and understand emission drivers to the Cyprus Institute. The last part of the presentation is about cities because, as you know, cities provide most of the wealth and economic output for humanity, but they're also big energy consumers, and therefore we can say that cities account altogether for about 70% of global carbon dioxide emissions from different sectors: power generation, ground transportation, buildings, industry, and waste. And in fact, cities have a responsibility for climate change, but they are also, at least many of them, are very strongly engaged into fighting climate change. There are many cities in the world that have ambitious plans to provide better urban planning and for reducing their emissions. And if those plans could be enabled, it could be a significant contribution to the goals of the Paris Agreement on climate. Yet, the problem is that 70% of greenhouse gas emissions originate from cities and urban areas. And if you look at the climate finance, cities today have only access or only using 1% of the climate finance. So there is more than $25 billion which are invested by cities, and they are not hooked up to the mechanisms that are in place in the Paris Agreement to reduce emissions. So they don't benefit from climate finance. At the moment, most of their emissions are voluntary. And I think the innovation here, we've been involved into city emissions for a while over the Paris region. Insofar, our projects have only met research users. We have a network of stations around Paris. We have inverted emissions from the city area, and we only interested researchers. But working with companies, in particular Origin Earth, which belongs to the Suez Group, what they are doing, I think, is very innovative. What they are doing is that they are managing credits from the Agence Parisienne du Climat, which is essentially providing subsidies and developing projects to renovate buildings in the Paris city. And those emissions today, they are just essentially money given by the city of Paris to reduce emissions. They don't have any financial value. And now the emissions will be essentially integrated into a market. Origin Earth has found buyers, people who want to buy carbon credits, so that there will be a revenue for the city and also, of course, a revenue for their financial services. So the key, I think, to induce cities to make more atmospheric measurements is to be able to give them back part of the investment they are currently doing into carbon credits, and this market will be underpinned by a carbon index that is based on the measurements we are doing around the Paris area. This model, I believe, is virtuous for climate change. It's also very efficient because it links atmospheric data as a carbon index to real emission reductions, and it will also enable the city of Paris to finance and to provide more emission reduction projects. If you go on the web, if you are a Parisian, you can calculate your carbon premium. Essentially, if you own an apartment in Paris and if you want to renovate it, you can have a significant subsidy on the order of 2,000 euros for a middle-sized apartment. And these credits will be essentially transformed into the market, and they will be acquired by different sectors. Essentially, this financial service is paid by energy providers in the Paris area. So we could develop the same model for many cities in the Eastern Mediterranean region, in Southern Europe and in the Middle East. And not only do we have the opportunity to install atmospheric measurement on the ground, but also we believe that satellites are credible as an option to track city emissions because there are not many clouds. Here you have an image of the OCO2 satellite. It's a track of the satellite showing a large excess when flying downwind, the CO2 plume of Riyadh. And the background curve is a model simulation of this plume, and it's possible to optimize the emission of the Riyadh city. It's an easy case because there is no vegetation around, and if you model the atmospheric dispersion, it's possible to say something about emissions. And here you have an image from the Sentinel-5P satellite, which is not CO2, but it also shows very nice, long traces of NOx, which are transported away from the Dubai city. So a user-centric service could be built around the environmental prediction and innovation department here to provide quantification of emissions of CO2 and also pollutants such as NOx, methane, and carbon monoxide. Last, there is a large avenue for innovation. If you imagine putting together the knowledge basis and the experience of CA with the striving innovation capabilities of the Cyprus Institute, we can have a lot of impact into developing the new generation of low-cost sensors that will lower the cost of carbon indexes for cities and industrial facilities. We have been using here a laser system with two sources in the center of Paris. They have a range of about 10 kilometers, and they sampled. We measured CO2 over a plain around the northern part of the city of Paris every 5 minutes during all weather conditions to provide estimates of the emissions of the cities. And we also developed in our lab low-cost sensors. They are about 60 times cheaper than the research class instruments, which are used in ICOS. And we showed that provided some careful calibration, they could do the job of measuring CO2 upwind and downwind gradients for industrial sources and cities, and they can all be put on board of UAV vehicles. So with this innovation strategy, I believe we can be very ambitious, and all together, with the help of standard agencies, we can try to work together to a global standard at world scale for monitoring city-scale emissions. This standard doesn't exist. We already have strong contact with the French Norm Association. Also, there is a strong initiative led by the US NIST, the National Institute of Standards, and coordinated internationally by the WMO IGIS project. There is an IGIS workshop in Paris next week, and hopefully by combining knowledge of models, satellite data, and innovative sensors and model, we can play potentially a very important role in setting up what will be the first standards for helping cities to monitor the effectiveness of their climate policy. So in conclusion, in the old world, I think we were living out of research projects, and those research projects have enabled us to develop capacities for estimating and quantifying emissions at the scale of cities, regions, and even facilities. This know-how should pave the way to establish EMME-CARE as the regional hub in the region for greenhouse gas and pollutant emission services. This kind of services will generate values because atmospheric measurements are needed in view of the problematic data we have now on inventories to support concrete emission reduction projects, and also, which is important, to leverage their financing based on upcoming satellite data and advances in lower cost sensors. So the idea here is really to go not for just teaming for research, but the long-term view is to construct a user-centric service for helping cities, regions, facilities operators to reduce their emissions. And of course, in the end, it is the people who will do this work, who will achieve this objective. And I would like to thank all our collaborators from LSE and Cyprus who are involved in this new adventure with you. Thank you very much for your attention.
So, to elaborate now on challenges and opportunities for climate change and air pollution impacts on human health, please welcome, on behalf of our advanced partner, the Max Planck Institute for Chemistry, the director, Professor Jos Lelyfeld. Small technicality.
Philippe doesn't want to go away.
Probably. Could I have some technical support, Mr. Garrido, please? Switch off. Yes. And then I can deal with the rest, I think. There we go. Please. Thank you.
So, Your Excellency, dear colleagues and friends, you see we have good technical support to solve problems here. I'm going to talk about climate change, air pollution, and focus a bit on impacts and on human health. And let me give you an outline. So I would like to discuss with you climate change and heat extremes. We've heard a lot about this already, but I think I need to address it again and maybe give you some more information. Wind-blown dust, tropospheric ozone, particulate matter, and their health impacts. And then the question was also to address scientific challenges and opportunities in this project. So this you've seen before, and I'd like to give you a little bit more background here. This is a business as usual scenario, the RCP 8.5 for IPCC. And what we noticed early on actually already is that the climate warming in this region, this is the MENA, the Middle East, North Africa, is not particularly conspicuous when you look at annual means. So if you look at the winter, for example, you see the warming. This is mid-century, December, January, February. This is end of the century. It's not very strong, more strong than what you see in the global mean. But if you look at the summer, you see all the colors here are red. So if the global mean temperature is rising by 2 degrees, then in the summer we are talking about 4 to 5 degrees by mid and end of the century. And you see here the Mediterranean is involved, especially if these scenarios become true. So there is an amplifying mechanism which has much to do with moisture. So if the moisture runs out, the soils run out of their capability of cooling themselves by evaporation, and then the temperature increases even more. Now, this was a model result. Actually, it was a model result. Let me go back. I'd like to tell you one more thing about these model results. This is from nearly 30 models that were being used in the IPCC. It's called Coupled Model Intercomparison Project Phase 5. This was used for the last IPCC program. Nearly 30 models, so we use ensemble results from these models. And you can see by the dots here is that the results are highly robust, which means that the models typically agree. There is very high agreement among the models that this is the warming that we can expect. And we can also, of course, compare the model output for the historical period. This is the reference period here. IPCC defines this as 1986 to 2005. Compare the model output with data that we have. We do have some data for temperature. Precipitation is more difficult, and we have divided the area into 4 boxes. And for each of these boxes, you see sometimes the models are a little bit too cool here, mostly in the winter, also here, a little bit too warm, but especially in the summer, the agreement is really excellent. So the models can also prove that they can do a good job on the historical period. And the main uncertainty, of course, is in the emission scenarios, because this is the human factor that is difficult to predict. We are trying to influence it. And on the precipitation side, you can firstly see there is much less robustness. There's almost no cross-hatching and stippling here. So there's much more disagreement between the models. This is much more difficult to predict. But what is quite clear is that in the winter, as well as in the summer, of course in the summer in this region there is not much rain, but it will become even less. And in the winter it will become less. And in some areas actually it will become more. So we will have more rain in this area, like the Sahel, the Arabian Peninsula, and this area. And this will become, this is also true in the summer, which is very important for the Sahel. Now, if we compare metrics that have been developed also for IPCC, this is a program called HEDEX2. These are measurements. You can see these are metrics for temperature: cool nights, cool days, warm days, hottest days, warm spell duration index. This is an indication for heat waves, which can also, by the way, occur in the winter. They're not as devastating, but we can have anomalous heating in the winter. So for this reason, we see many days of these heat spells increasing. But you can see the models, there's a wide range actually. This is the maximum and the minimum, and this is the statistical range, the spread, and this is the average, the black line. And you see the blue line is very much, in many cases, on top of the black line. I always find this intriguing, that if you take one individual model, you get an answer. If you take 30, you get an enormous spread, but the mean of the results is spot on the measurements, which is quite remarkable. This has also been the philosophy of the IPCC with their ensemble modeling. Now, if you look at heat extremes, this is, of course, the weather is a stochastic process, so it's like a bell-shaped curve, a normal distribution of the weather events. And of course, you have cold extremes and heat extremes. But if the mean increases, obviously you'll have more heat extremes. And the question, of course, how this plays a role here. And this is an image that was also shown by Professor Jarreau last night. You can see here, this is the curve here for the reference period, which was taken here from 1961 to 1990. We define the climate often for periods of 30 years. And we see that the curve is shifting to the right. And obviously, these extremes, and this now is not an extreme scenario. This is the middle scenario. And you can actually recognize that from the fact that from the middle to the end of the century, the shift is rather small. So in the intermediate scenarios, it's assumed that by the middle of the century, the carbon dioxide emissions are really reducing. And, but still, you can see if you take this scenario, the average is increasing to about 40 degrees, but more than 5 degrees. And these extremes that have never occurred before in Nicosia will occur. And this is something that we really need to prevent. This is why the region is a hotspot. This was also found by others. By the way, the results that I'm showing is the combined results from our institute in Mainz and the Cyprus Institute. I haven't listed all the papers and the names, but I'd like to thank, of course, all the team members that have contributed. This is another team from MIT looking at this region. And what they've looked at temperature maxima in regional climate modeling output. And DOM is the domain average mean, so the mean over this area, including land and sea. And you can see this is the temperature range that in some parts of this region, we're talking about temperatures, maximum daylight temperatures in summer of the order of 60 degrees. This is life-threatening. And this is something that you can also see here. This is what they call the wet bulb temperature. This is the temperature that is representative for 100% relative humidity. And this is extremely relevant for human health because at 100% relative humidity, your body cannot transpire metabolic heat. So you transpire because you need to get rid of your metabolic heat in your body. And if the temperature and the humidity become so high that this is no longer possible, you will die. And this has been defined at 35 degrees. And the reason is that your skin temperature is 35 degrees. So if we reach wet bulb temperatures of the order of 35 degrees, which are getting very close here, this is over the sea, but also the coastal areas, the atmosphere becomes a deadly environment. This is really absolutely horrendous. This is something that we absolutely need to prevent. And I was really surprised to hear this morning that the awareness in the Middle East about climate change is so little, because these are the sorts of things that will happen if nothing is being done about this. Now, we also looked at heat effects on human health, and here we had the help of the Ministry of Health and the Department of Meteorology in Cyprus. You see here pushing the wrong button, sorry. You see here the meteorological stations that have been used to do this study, and the health data came from the ministry. Of course, they were anonymized. And this shows you, and this has also been shown by a few other studies, the effect of heat waves on mortality. And these are mostly cardiovascular mortality, so people die from heat stroke or heart attacks. And you can see here, this is the temperature, this is the maximum temperature, this is the mean temperature. What is also relevant is the minimum temperature, because at night you can actually stand quite a high temperature during the day, but during the night your body needs to be able to cool down a bit. And if temperatures are getting too high, what we call tropical nights above 25 degrees, then this capability is strongly minimized. So both the maximum and the minimum temperatures are really important for these studies. And you can see shortly after these heat events are occurring, you have something like a 40% higher probability of dying from a heart attack or a stroke. So this is a very significant number. Another aspect of health related to climate change is from mosquitoes. Of course, you have all heard of malaria as a vector-borne disease, but there are many other diseases that are being carried by mosquitoes. And this is one nasty one. This is called Aedes albopictus. It used to be called, or actually the official name is Asian tiger mosquito, but I'm now leaving the word Asian out. This is the tiger mosquito. It has already invaded Europe. It's already there. It's being brought in there mostly by shipping. So international cargo shipping bring in these mosquitoes. But then if the environment is favorable, if the climate is favorable, then the mosquitoes can thrive and they can become a health threat. So the diseases that are relevant here are chikungunya, yellow fever, West Nile, dengue, and most likely also Zika. That was where we had an outbreak in Brazil last year. And this is from the European Center for Disease Control, and you can see in 2019, the mosquito was endemic in these red areas, and it also invaded already some of the yellow areas. So it's already found in northern parts of Europe. It invaded Europe about 30 years ago, and the same is in the United States. And also in the United States, it's moving up very quickly. It came in Florida. This is the original area where these mosquitoes come from. And we have run climate change scenarios to look at how this might develop. And we find that some areas may become less favorable for these mosquitoes. Actually, the area where these mosquitoes come from This is the blue, and the red areas are the areas where the mosquitoes will have better chance for survival. So it's no surprise that actually these mosquitoes are moving up very quickly in the United States. They're moving up north in Europe and the United States. And one thing that was mentioned also this morning is rain. And this is actually a big issue because even though there is not a lot of rain in the Middle East, sometimes it comes down in torrential events. And this has happened also earlier this year. And I don't know if you remember one of my earlier slides showing that some of these areas will get wetter. These extremes actually have occurred throughout history. So it is not something that has not occurred that is suddenly occurring. But actually, the occurrence of these events mostly was in the winter. They're now moving also into the spring. They're starting to move into spring. It's very difficult for us to link this to climate change because they happen, say, once a year, once every few years. So the statistics that we have on these events is very low, so that we cannot really study them, but it is very clear that, you know, occurring in seasons where they have not occurred before and really also affecting infrastructure. The fact, of course, also is when the area is so dry and cities are not prepared for it, then the water cannot be moved out of the city, and actually people drown in the desert in these events. This is really something horrible that has been happening in the last decades. This was also something that was picked up by Vice President Al Gore. He invited us also to participate in his events. And this is what his last book, Truth to Power, and he cites our work. The climate in large parts of the Middle East and North Africa could render some regions uninhabitable, which will surely contribute to the pressure to migrate. This is something also of extreme relevance also for Europe. So not only for the region, but these people will also have to be accepted somewhere else. And ethical issues come in, practical issues. This is something that really needs to be prevented. So now I'd like to move into air pollution. Thanking Andrea for making this simulation. We've heard already that dust is an issue here, other pollutants as well, and we will see them here. Actually, the brownish stuff is organic carbon, we have black carbon. Water soluble is actually reddish, we will see it later, dust. The particles also attract water vapor, and this is very relevant, not so much for health, but for climate, because when they attract water vapor, they will swell and they will reflect more sunlight and contribute to climate change. And of course, we also have sea salt. So we see dust moving westward in the trade winds from the Sahara, but also in the mid-latitudes moving northward. You can see dust is all around. This is, of course, in the Sahara. Not too many people live in the Sahara, but other regions are being affected downwind. Also the Middle East, we have a lot of dust. And here you see the reddish colors coming in. This is anthropogenic pollution from ammonium sulfates, ammonium nitrates. That is all anthropogenic, attracting water also. See over China, for example. Stuff is being transported over the Pacific, where it, of course, does not affect health, but affect climate. Over the United States, which, of course, itself is also a big source of air pollutants. And this is running in a climate model. So we're interested in making the link between climate change, how these pollutants contribute to climate change. The dust has a very obvious contribution. We don't know very well how much of the dust is anthropogenic. We're guessing something like 25%, because people have contributed to desertification. But the dust is also, in its properties, is being affected by pollutants attracting to the dust, changing their toxic properties and also their climatological properties. So these are the sorts of things we want to study here, and then link them into these models to be able to use these models to support policy making. Now coming back to the dust, this is Klaus's work. We see here, this is aerosol optical depth observed from satellites. Satellite is called MODIS from 2000 to 2015. You see in some areas, actually, there is a significant decrease of aerosol pollution in some of Europe, actually. Not so much in the Eastern Mediterranean, unfortunately. And this could have to do with the dust, because we think this is related to dust. This is a very strong upward trend, and this is being made more clear here. We see the Arabian Peninsula, the same data here. same period, and we see here, this is all significant with the dots here, very significant increase in dust. Actually, in this period, the amount of dust in the already dusty region has increased by something like 70%. And we now think this is related to the fact that there were droughts and issues in Syria and Iraq. The farmers left the lands, and this also contributed to uproar. The farmers were complaining to the government, help us. The government in Syria didn't do anything. They just used violence to suppress the legitimate claims of the farmers, and then the people started to migrate. This is what happened. So you cannot say climate change was the cause of this problem, but it certainly was part of the problem, and this is what happened. And we see this in the dust also coming mostly from Syria and Iraq in northerly winds spreading over this area. Like I said, we try to put this into models. So here we have our models called EMME-CARE. Here we compare with satellite data at about half a micrometer, 550 nanometers wavelength. Also at 10 micrometers wavelengths, which tells us more about the dust, which are the bigger particles, which are measured at a larger wavelength. And here we see what we call the dust belt. This is a snapshot from what you have seen before. And you can see the regions that are really affected by the dust. Some of it actually from the Sahara is transported also to Middle and North and sometimes South America. But of course, this is the region, the hotspot of the dust region. But there are also deserts here, like Gobi Desert. Also India has the Thar Desert. So this is the desert area that is creating a lot of dust in the world. So we try to reproduce that with models. And we look not only at satellite data, but also at surface data. You see here different background stations. Here you see this plume again was being modeled. And here we compare with data. You see we have some issues here at low concentration. So these are these stations here in the Pacific. So our model transports too much dust to these stations. And we have to find out why. We also look at deposition. This is a very difficult measurement because people basically measure how much stuff comes down in the atmosphere. It's not very accurate, but nevertheless, I think we can also say here that we are doing a reasonable job on making these calculations. Then ozone was mentioned. This, of course, is a famous problem in California, and it still is actually. It's become less severe, but it still is an American problem. But it is also a Mediterranean Middle East problem. You see high ozone concentrations, especially in the summer. And these arrows indicate the wind direction, and you can see the wind is mostly northerly. And this is what we also observe over the Eastern Mediterranean, is that pollutants are being picked up in Eastern Europe, Central Europe. There is a lot of agricultural burning, there is a lot of industrial pollution, the emissions are not controlled. That comes towards the Mediterranean area and is being transported further into the Middle East. And of course, this forms the background on which the local emissions are forming smog and etc. Also here we can show that this model does a reasonable job. Here you see the development of measurement stations in Europe. And here we compare with the measurement stations, and you can see the model is doing a fairly good job also in the spread compared to the data, which are in black, and the model results are in red. This then we use, we work in collaboration with, got stuck here, with public health specialists. So I can't move the presentation, but I can tell you about it. Maybe somebody can help and I can continue talking. So, there it is. So we are working with public health specialists who have been performing epidemiological studies for decades. So they have quite a lot of data on the impact of air pollution on human health. One of the issues is to really quantify exposure, because some areas like Europe, for example, or the United States have quite dense air pollution measurement networks, but okay, maybe the image is too big. But we need models actually to interpolate between these measurement stations. And so we use models, we use satellite data, we use ground-based stations in order to quantify the exposure of humans to air pollution. And then we apply the factors, there it is, that are being provided by the public health specialists, and then we make these calculations. And this is from a publication earlier this year where we had to update the epidemiological data. At least we didn't do this. This was done by their community. And they now included more than 40 what they call cohort studies, is where they have followed human communities for more than decades and looked at health impacts. And we see here premature mortality. This is something that is sort of scary, but it's also a bit difficult to explain because you lose life expectancy. It's not so that when you inhale air pollution that you die immediately. It is like with smoking, it sort of accumulates the problem, and at the end of your life you will get diseases that shorten your life. And here we see the loss of life expectancy. And like I said, this was published earlier this year in a medical journal. And it created an enormous outrage because one of the conclusions of this paper is that air pollution has a similar health impact as smoking. So it's a similar public health threat as smoking. And this was, for example, not known in the cardiology community. Cardiologists think that smoking is one of the main causes of the problems that they try to treat, but actually air pollution is at least as large a problem. Now, scientific challenges and opportunities from our work, I think we need to go further to high-resolution modeling because we have issues with surface topography, land sea breeze circulations, which of course is very relevant for islands which are not well represented in climate models. This is certainly a challenge where we need to improve. The opportunity will be is that we have better forecasting systems, so we can better forecast extreme weather events, air quality, other hazards, and we can help develop early warning systems that help governments and policymakers. Another challenge is emission inventories. This was mentioned by previous speakers already. The emission inventories in the region are very poor. We can see from satellites that there are point sources that are there which are not being reported. It may not be a bad intention, but it is simply not working. So there we really have to do more. Then we can use these data as simulate them in models to improve our, for example, exposure calculations. A challenge is regional Earth system modeling. There are a few groups that are already involved in global Earth system modeling. We are doing that also, but I think we need to make the step to regional Earth system modeling because these specific things like dust, etc., dryness, need to be addressed on a regional scale. The opportunity will be is that we can be better represented in the IPCC process with our regional model output and our regional studies. Another challenge is downscaling to the urban environment. In the Middle East, about 70% of the population lives in the urban environment, which is a little bit more than 50% globally. Of course, it's a bit difficult to live in the desert, so in this region, most people live in the urban environment. So we need to downscale to the urban environment. This is definitely a challenge. And then, of course, we will have the opportunity to help policymakers and decision makers in areas on public health, society, economic sectors, also agriculture, of course, with water availability and projections of what is coming in the future. And with that, I would like to conclude and thank you for your attention.
Thank you, Professor Lelyveld. EMME-CARE is commencing a wonderful journey, and it's commencing with it its scientific endeavors. There are a lot of challenges to face, but also a very strong teaming, as you see, to capitalize on. Please welcome the EMME-CARE coordinator, Professor Jean Siard, for his concluding remarks.
First, I would like to really thank all of you for being here today. It was a chance for us to present what we would like to do, and with all these people that are not necessarily from the Cyprus Institute in the audience, I really hope that we have motivated you to engage in this teaming with us. So it's not just a consortium of 4 partners. It's, as you could understand from the ministry this morning, and our president of the Cyprus Institute this morning as well, it's a national effort, it's a national initiative. So we are really hoping that this will create even more collaborations at national level and then at the regional level. So This is just the start of a collaboration, hopefully, with all of us, with all of you. And I will finish this morning session with thanking also all my management team that was supporting the organization of this event in a very well manner. And we would like to kindly invite you also for a light lunch that will follow up. Thank you very much for your participation.
Dear friends, just a bit of housekeeping. Those who are not joining the tours, please note that at 1:30 there will be a minibus to Landmark Hotel. Another housekeeping rule, those visiting the tours, the facilities, please be ready by 12:30 and find me, and I will guide you to colleagues who will show you around at the facilities here. And then 1:30 is the minibus to Landmark Hotel. 12:30 is the beginning of the tours of the on-site facilities here. Lunch is now. That was my last point. Lunch will be starting, I think, in